So here are some ideas I have to improve 3D printing. Some of them are just software changes. The first idea I have is that different layers in a material respond to stress differently. Typically, in 3D printing, you make something layer by layer, and the weakest thing is where the layers are joined in between. In between these layers can split. Now, this means from a peeling motion or from forces that are parallel to the layers. One way of fixing the strength is to print them in different directions. So if I print some of it this way, then print some of it this way, with layers being printed in different directions and stuff, and filaments, you can increase the strength a lot by having everything in the right direction. If you could have a plug-in to your Axle 3D printing things that figures out how to customize your build for different stresses, you can make something potentially a lot stronger. Sometimes it can be over 50% stronger in certain directions. You could also do this for vibrational dampening and stuff, how stuff vibrates and more. But this might sacrifice speed because you're changing directions more often. So you could do like a compromise between speed and strength and build in like different parameters with one function, like make it this much stronger only if it doesn't take this much longer. And all these things could be built in eventually into standard 3D printing software. Another thing you could do with this is if you have all the stress testing, it could also be easy for people just by themselves to design things and figure out how strong it is instead of going to fancy people to do it. So it'd be nice to plug in. Another thing is another way of proving this would be with having more axes here. So normally we just have an axis for 3D printing up and down, left and right, and side and the other side to side. But if you have now one that also can turn it or move in more directions, you could cause it more quickly to change the directions of layers or print out more complicated paths more precisely, which would help increase strength even more. And would also help with the speed drawback if it can go diagonals faster or just turn around. But that, of course, means a more complex setup, and instead of being the first one was just software. Another thing we could do is have it examine how the different layers impact each other with remelting and stuff. Because when you put a layer on top of another layer, they fuse by somewhere in the middle, melting a little bit together. Now, the fusion is different in different ways, and that can have drawbacks or not. It can lead to less precision if it's higher melting point, but it can lead to better fusion between the layers and strength. So having something that also customizes strength by looking at that, so maybe melts at higher temperature in places that you don't have to be as inaccurate as like the middle device, or it melts at higher temperature when it wants to actually get them flatter so it groups down. We can also change the extrusion speed maybe to make it have different parameters here, so it affects stuff more or less with how much it fused together, or speed, or delicate. But these are mostly software ones. Even though the more modifications with melt speed and stuff like that, you could do the better 3D printer. So software and hardware go hand in hand there. Another one would be have more devices built into it, such as a device to remelt part of the plastic to better fuse it together, or to carve out details, or in other ways just smooth it on actual device so you can build it more at once and continuous and fancy safe instead of going back and forth. We might have problems with alignment because then you have to realign everything, leading to less accuracy. Another idea I have, which will require probably fancy instrumentation, is that everything has to do with calibration and stuff like that. And also learning parameters has to do with learning new parameters. You have to test out stuff repeatedly. But what if you had an optical feedback system that could learn what works and not works, see that's like too high a temperature, too low a temperature, how different things are reacting. But it could also see if the bed's not level, it uses an optical system to figure it out and correct for it, or if that whole thing is shaking, correct for it, or something else that corrects for the little things that normally you have to calibrate for. Another idea I have is for dissolvable supports for the system, which you can think would greatly help the system in that you could make more complex structures and support them in weird ways, then dissolve the supports, or you could level the bed that way. Auto surface leveling with both optical fiber, dissolvable supports, and other ways of like surface measurements with more sensors. And lastly, an auto stop function if it sees with any of these methods that's way out of whack and stuff, so you don't ruin the whole thing. Let's say there's an earthquake or something and your device is destroyed, so it stops and doesn't cause a whole mess. Well, thank you very much for listening to me. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Goodbye.